3.7. This is actually 3.7 and 3.8 combined. 3.7 is talking about equations of lines in the coordinate plane. Coordinate plane should make you think distance formula, midpoint formula, and we are going to add in our final third formula, which is the slope formula. And the slope of a line is basically the steepness of the line. And vertical and horizontal distances are used to determine that steepness. So we are going to talk about steepness, which is also known as slope. And 3.7 is basically a review from algebra. We have a definition here. Slope, if you recall from algebra, slope is defined by the variable m. M is slope. The slope of a line is the ratio of the vertical change to the horizontal change between any 2 points. So just like with all of our other coordinate geometry, coordinate formulas, we are going to use points x1, y1 and x2, y2. Always make sure that you are labeling your points, identifying them, and then labeling them. It will make life easier. If you remember from algebra, slope is rise over run. If you have a nice graph, you can use rise over run to find your slope. We like to be lazy, but we have a formula. Slope is y2 minus y1 over x2 minus x1, and that will always work, always. So if we have a line and we choose 2 points on that line, then we can rise. You always rise from the left point. You always rise first, either up or down. Down would be a negative rise. And then you run will always be in a positive direction. And we can label our points x1, y1, x2, y2, and use our formula. So let's look at an example here. We are asked, what is the slope of line B? So let's find line B, and there it is. And we are given 2 points on line B. Now, we can count this slope, and we always work left to right. So we could go down and over, and we would rise 1, 2, 3, 4. So that would be, if we do rise over run, that would be a -4 over, and how many do we run? 1, 2, 3, 4, 5. A -4 over 5. And you always simplify your fraction if possible. Or, if we like to be proper, we can choose our 2 points. And our first point is, let's see, they use this one. Y1. They use the bottom one. 4, -2, and -1, 2. And we would label those x1, y1, x2, y2. Doesn't matter what order you use. And then we use our formula. We do y2, and don't forget that this is a minus. And then you put in y1. Here y1 is a -2, so we do 2 minus a -2 over x2 minus x1, and order matters here. So this is why you label your points. So it's a -1 minus, and then x1 is a +4. And look, we get the same slope. So the slope of line B is -4 over 5. The next one is the slope of line D. So let's find line D. Line D goes straight up and down here. What do we know about the slope of vertical lines? Well, if we choose 2 points on that line, how many do we rise? Well, we rise 2 and run 0, right? So slope, if we do rise over run, we rise 2 and run 0. And you can't divide by 0, so that's an undefined slope. We can also use our points. That's 1. So we would use our points for -2 and for 0 and label them x1, y1, x2, y2, and then we would put them into our formula. y2 minus y1 is a negative, so it's minus a -2. Minus a negative is plus a positive. And x2 minus x1, and we get the same thing. So for this one, the slope of line D equals 2, 0. All right, so that's just this should just be a review. So go ahead and pause the video and do the next couple of problems. Okay, we were asked to find the slope of line A, so that's our blue line over here. I wrote down the 2 points that were on that line. I labeled them, put them into my formula. I always approve of writing your formula. Put them into my formula and found a slope of 4/3. Now, if we go over to our line, and we have a nice graph, so we could count this. So I drew my triangle. I always rise from the left point to the right point. I rise 4, run 3. So that's confirmed. And the second one says, find the slope of line C. Line C is our horizontal line up here in green. And I found my 2 points, labeled them, put them into my formula, and I got a slope of 0/4. And you should remember from algebra that the slope of a horizontal line is 0, just like the slope of a vertical line is undefined, because a horizontal line, you're not changing. There is no rate of change. It is just a constant. If you have your bank account, the amount of money in there is just constant. It's not increasing, it's not decreasing. So that's slope. That's all we're doing from 3.7 is getting our slope formula. We now have our 3 coordinate plane formulas to use with our coordinate geometry. Distance formula, slope formula, and midpoint formula. Those will come in handy. Don't worry, we will be using them. So let's look at 3.8, and this is what really matters to us as far as geometry goes. We are going to talk about the slopes of parallel and perpendicular lines. And we know what both of those are. Parallel are our coplanar, do not intersect. Perpendicular, intersect at a right angle. Coplanar, intersect at a right angle. And we can determine if they are parallel or perpendicular using their slopes. So our first one here is the slope of parallel lines. And if 2 non-vertical, so they're not straight up and down, if 2 lines are parallel, their slopes are equal. So we can make a note here. Parallel lines have the same slope, and M is slope, right? Same slope. If they have the same slope, we know they are parallel. And this is same for, we can say the opposite of that. If your slopes are equal, then your lines are parallel. So if we have lines are parallel, then slopes are equal. And if slopes are equal, so our slopes are equal, then our lines are parallel. Notice we have a conditional and its converse, and they are both true. Now, something important to remember here, any 2 vertical lines or any 2 horizontal lines are always parallel. So what do vertical lines look like? Well, we could have y equals -3. would look like that. And say y equals 5. Anytime we have two vertical lines, they are always parallel. And what do horizontal lines look like? Well, that would be, say, x equals 6, and I'm doing this backwards. Let me do this backwards. These are x equals. These are y equals. That makes so much more sense. And y equals -2. Any horizontal lines are always parallel. This will also come in very handy later on. It will save a lot of work. We saw up above that we can calculate the slope, and that's just fine. But if we know this right here, if you have vertical lines, your x-equal lines, those are always parallel. If we have two horizontal lines, your y-equals lines, those are always parallel. All right, let's look at an example. We're going to check if our lines are parallel. Are lines L1 and L2 parallel? Well, I don't know. They look parallel. How are we going to find out? We are going to check their slopes. So I find the slope of L1. I take my 2 points. I label it, that's not L1. L1, find my 2 points. Label it x1, y1, x2, y2. Substitute it into my formula, and I find the slope of L1 is a -3. And I do the same for line 2. Sorry. x1, y1, x2, y2. Substitute in my formula, and I find a slope of L2 is a -7/2. Now, are those two numbers equal? No. Because those numbers or slopes are not equal, the lines are not parallel. That's worthy of red. We should do that in red. Those are not equal. Your lines are not parallel. So even though they look parallel, they're not. They are eventually going to cross somewhere because our slopes must be equal for lines to be parallel. All right, your turn. Go ahead and pause the video and do the next problem. All right, well, we were asked if line L3 and line L4 are parallel. So we labeled our points, put it into our formula. We got the slope of line L3 is a -1/3, and the slope of L4 is a +1/3. Now those numbers look an awful lot the same, but they are not. So they're not parallel. So be careful, watch those negatives. All right. When two lines are perpendicular, your slopes will be opposite reciprocals. That means that the product of their slopes is -1. But all you have to remember is they're opposite reciprocals. So what does that mean to us? That means if the slope of line 1 is a +3, we always make slope a fraction because it's always rise over run. Then the slope of line 2, which is perpendicular, your perpendicular slope, we'll just call it perpendicular slope, is going to be opposite, which would be a negative, and reciprocal means flip, 1/3. Now, what if our slope of our first line is 2/3? Let's make that a -2/3. Come on, eraser. So if our slope is a -2/3, what is our perpendicular slope going to be? M perpendicular is going to be opposite, so that would be positive 3 over 2, reciprocal. So we flip it. Okay, perpendicular lines have opposite reciprocal slopes. And if you look here, what is 3 over 1 times negative 1 over 3? That's a negative 1. Negative 2 over 3 times 3 over 2. We can actually look at that. 3 over 1 times negative 1 over 3 is negative 1. Negative 1, right? Our 3's cancel. We should probably do it properly if we're going to do it. This would be a negative 3 over 3, which is just negative 1. If we do a negative 2 over 3 times positive 3 over 2, we could cancel, cross cancel, or just negative 6 over 6, negative 1. Cross canceling is good. One thing to remember is that any horizontal line and vertical line are going to be perpendicular. Again, this is going to come in handy later on. So if we have a horizontal line A, which is y equals 2, and our vertical line B, which is x equals negative 5, these are always going to be perpendicular. We will be able to say that A is perpendicular to B. So any horizontal and any vertical line will always be perpendicular. Just like two horizontal lines are always parallel, two vertical lines are always parallel, a horizontal and vertical line will always be perpendicular. So you're saying, well, how do we check if lines are perpendicular? Well, we look at the slopes. So we choose our first line. So we choose line L1. There are our points. We label them x1, y1, x2, y2. So this is x1, y1, x2, y2. And then we put them into our formula. Oh, I got that backwards. It doesn't matter what order you put it in. I'm just matching up to the problem here. So x1, y1, x2, y2, you will get the same answer no matter what you do. So that's not true. I had it right the first time. Sorry. Like I said, it doesn't matter. So x1, y1, x2, y2. All right, so we do, yeah, there we go. 2, don't forget, this is a minus, and our y1 is a negative 4. Minus minus is plus plus, over a negative 4 minus 0, and we get a slope for line 1 of negative 3 over 2. And then we go to line 2. Here are our points. They do 3, 4. So this is x2, y2, x1, y1. We do 3 minus a negative 3, and 4 minus a negative 5. And we end up with 6 over 9, 3 plus 3, because minus minus is plus, and we get a slope of positive 2 over 3. Now, are these slopes, are these lines perpendicular? Well, are our slopes opposite reciprocals? You can check the product. A negative 3 over 2 times a positive 2 over 3 is going to be a negative 1. Or, just can we take the first one? And is it opposite? Yes. One's negative, one's positive. And are they reciprocals? Can you flip them? Yes. So these lines are perpendicular because their slopes, the product is negative 1, or they are opposite reciprocals. I will accept both answers. All right, and we are almost done. It's your turn. Pause the video, do the last problem. Okay, we were asked to find out if our lines are perpendicular. So I took my points, I labeled them, put them into my formula. I got the slope of line 3 to be a -8. And I always like to keep my slope as a fraction because it's rise over run. It's a rate of change, so -8 over 1. And the slope of L4 is 1 over 10. So unfortunately, no, these lines are not perpendicular because, and it says explain, because our slopes are not opposite reciprocals, or we can multiply our slopes and they come out to be a -4 over 5, which is not -1. Their product is not -1. We should write that. The product is not -1. So I will accept either answer. They're not perpendicular because their slopes are not opposite reciprocals, or their product is not -1. So this is a nice little algebra review, and slope is going to come in very handy when we do coordinate geometry with figures, especially like quadrilaterals. All right, this is kind of a fun way to end the chapter. I'm sure you will do very well on this homework. Enjoy.